Yes. So the new chapter, that is dimensional. One second. This is now chapter. Okay, we are discussing the last chapter, that is dimensional analysis, and similitudes. Okay, dimensional analysis and similitude. So actually, the dimensional analysis is what it's a mathematical technique which deals with the dimensions of the physical quantity involved in the phenomena. Like suppose some problem of a fluid mechanics are very complex in nature and also very difficult to solve. So the solution of such problem is considerably simplified by the use of dimensional analysis. Okay, and it is based on the assumption that phenomenon can be expressed by a dimensionally homogeneous equation with a certain variables. So advantages of dimensional analysis is the functional relationship between dependent and non-dependent variables can be expressed into dimensionless terms. Okay, now what is the variable? What is the dependent terms and independent terms? I just tell you in a few minutes. Then the advantage of dimensional analysis is in model testing. It reduces the number of variables into 3 numbers. Okay, so by the dimensional analysis, design curves can be developed from the experimental data or the direct solution of the problem. Okay, so yes, we just start with the fundamentals like the fundamental and secondary dimensions. So various physical quantity used in a fluid phenomenon is formed by some fundamental quantities or primary quantities such as mass, length, time, and temperature. So if you see the fundamental quantity, okay, fundamental quantities. So fundamental quantities are nothing but the mass, length, time, temperature. Okay, so the unit of this physical quantity which does not depend on the unit of any other physical quantity is the fundamental quantities or fundamental dimensions. So mass is not depend on other quantity, length is not dependent on other quantity, temperatures, and the time. Okay, so these are nothing but the fundamentals. The unit of a physical quantity which depends on the unit of the other physical quantity, that is saying it as secondary quantity, secondary dimensions. This may be written as fundamental quantities or fundamental dimensions. Or the next is secondary quantities or secondary dimensions. Now, what are the secondary dimensions? Where the physical quantity depend on the other, I just say the physical quantities. Like suppose we just take an example of the force. Okay, now how it is depend on other, no? We just see in few minutes. Force, then next is the angular velocity. Okay, angular velocity, then discharge, torque, okay, power, power, then viscosity, viscosity, after that the density. So these are nothing but the secondary dimensions. Okay, so these are depend on the other physical quantities. We just see one by one. Fundamental, you just see that is the mass, length, time, temperature, and these are we can formulate into the simpler form. How to make it into a simpler form or make it into a fundamental quantities? We just see that separately. Okay. So suppose yes, that is the secondary dimensions, which depends on the other fundamental dimensions. Okay, this is secondary dimension. So I just told you that is a force. Now how to write force? Force is equal to what? That is mass. Force is equal to mass into acceleration. Is it okay? Mass into acceleration. So now we just simplify this. Mass means how to write the mass. Mass I can write it as m in fundamental quantities. That mass we are representing it by capital M multiplied by acceleration means what? Acceleration, if you see that is I just say velocity by time. Is it okay? Velocity by time. Okay. So how to write? If I again simplify this, can I write velocity is equal to displacement by time? Displacement divided by time. Can I write this? Yes, we can write. So if I have to write this in a fundamental dimension, this is velocity v. Okay, displacement I can write it in terms of length divided by time t. Is it okay? Is it okay? That means v is equal to L divided by t. So can I put this value in a term that is m into velocity, that is L divided by t? Is it okay? Divided by t, again that is time. Okay, no, this time is t. I just put the values here. So can I simplify this again? M multiplied by L multiplied by yes, oh sorry, divided by t square. Can I write this as t square divided by t square? We can write this. So in case of the dimensional analysis, I just write the force F. Okay, we are representing the force by F is equal to M L. Okay, and T raised to minus. This is the another format you just have to remember. T we have just taken it in upward side. Okay, so this is the way to write the dimensional analysis. Next term that we just see, this is our first term. The next term if we see, that is the angular velocity. Angular velocity. Angular velocity. That is equal to angle covered in radian. Angle covered in radian divided by time. Okay, so angular velocity we are representing it by omega, that is equal to, so angle covered in a radian means per unit radian we are taking, so that is 1 divided by t. Time is t. So can I write this omega is equal to t raised to minus 1? Okay, t raised to minus 1. In the same way, the third quantity is discharge. Discharge. Okay, so discharge is equal to what? We know the formula. That is equal to area multiplied by velocity. Is it okay? Area multiplied by velocity. So how to write this area? Area is what? That is length into length. Can I write L square? Yes. Length into length, L square. Multiplied by velocity, we just have written L divided by T. So L divided by T. Okay. So if we simplify this, can I write this as L cube, okay, and T raised to power minus 1. Discharge we are denoting it by Q. So discharge we can write this as L cube T raised to power minus 1. The next quantity is what one? That is torque. Okay, or moment. That is angular moment. So torque we just write it as force multiplied by force. If it is a moment, that is force into distance, obviously. Force into distance. So force is equal to what we have written here. So we just put directly the value of force here. Okay, that is equal to m l t minus 2 multiplied by distance l. So you will get m l square t to the power minus 2. T to the power minus 2. Torque we are going to write it by T, capital T. Okay, so these are the secondary dimensions and how to write it in a fundamental way that I just have shown you. Again, we'll take a few examples so that you are being familiar with that. Next is a power. Power we are representing by P, that is equal to work done divided by time. Work done divided by time. Okay. So work done is equal to what? That is force into distance. Work done equal to force into distance divided by time. Okay. So the value of or the how to write force in case of fundamental we just have seen. So I will directly put the value of force m into L into T to the power minus 2. Don't remember it. Okay, just see that how it has been solved and try to remember the procedure and go with the procedure. Don't remember directly the formulas. Okay. It is quite difficult to keep that in the mind. Time, we just write it as capital T. Like, if you simplify this, can I write m into L square and t raised to minus 3? T raised to minus 3. Okay. The next is this is fifth quantity. Next is the sixth quantity, that is viscosity. Viscosity. Okay, so viscosity, we are representing it by mu, that is equal to shear stress divided by shear strain. Shear strain. Okay, so shear stress is what? Force divided by area. Force divided by area divided by shear strain. Shear strain means what? That is du divided by dy. So force, the value of force, we know that it's actually m L t minus 2, that is the force, divided by area. Area means L square, we know that, multiplied by shear strain. Multiplied by shear strain. Shear strain is what? Du by dy. Okay, so u is what? That is the velocity. So how to write velocity? That is L divided by t. Okay, and divided by y, that is L. Okay, so if you simplify this, you will ultimately get m L raised to minus 1 and t raised to minus 1. Okay, so here L get cancelled. This one, so you will get L raised to power minus 1 and t raised to power minus 1. Okay, so this is the way to get the secondary quantity. Last quantity we just see, that is density. Density. So density, we are representing it by rho. So rho is equal to what? Density is equal to mass divided by volume. Okay, so mass we are writing m, and volume means length into length into length, means L cube. So if I have to write that in dimensional terms, m into L raised to minus 3, like this. So this is the way how to write the fundamental terms. So many terms are there. If you see in textbook, you will get the so many terms. Okay, you can write any term in terms of fundamental uh, in terms of fundamental quantities. So I have just shown you the few quantities of that. Okay, just try to do by your own for the different ones. Then what we just see, the dimensional homogeneity. Now what is dimensional homogeneity? Dimensional homogeneity. Okay, so what is actually a dimensional homogeneity is analysis is based on principle that variables in a physical phenomena is arranged properly to give an equation which is dimensionally homogeneous. The equation which dimensions of left side is equal to dimension of right hand side. So actually what is that? I will just uh, give an I will just demonstrate with an example. Like suppose you know the frictional loss formula, that is Darcy-Weisbach Darcy's equation. Okay, F is equal to, what is that? FL, so V square divided by 2GD, this formula. Okay, so in case of left hand side, if I take dimension of left hand side, okay, that is what HF. So HF is what? That is actually head loss. So head loss we are always taking in terms of height. Okay, nothing but if I have to measure the height, that means I can write it as in terms of L, that is meters. Okay. In the same way, if I just solve the dimensions of right hand side, dimension of right hand side. So that is equal to what? That is equal to FL V square divided by 2GD. Okay. So in this case, what you have to take the constant, that is frictional coefficient value, as a 1. You have to assume. Okay. Then the next is neglect the constant term, that is 2 in a denominator. Okay. So these two you have to 2, that is going to be neglect. So if I write or simplify this, friction value 1 multiplied by the length, okay, L, multiplied by this is V square. This V square means velocity square. Okay, velocity, how to write velocity? Distance divided by time, L by T, and that is whole square, divided by 2. We just have to neglect 2. Okay, multiplied by G. G means acceleration due to gravity. Now acceleration due to gravity means what? That is if you see the unit, that is meter per second square. Okay, so can I write meter as a L divided by second square as a T raised to 2? Okay, so L into T to the power minus 2. This is acceleration due to gravity. We can write. So L multiplied by T raised to minus 2. T raised to minus 2. Okay, multiplied by D. D is what? D is the diameter. So diameter we are getting in terms of meters. So that is L. So if you simplify this, L get cancelled. Then here also I think yes. So here again T raised to minus 2 and T raised to again minus 2. So that is going to cancel here. Ultimately you will get the answer that is equal to L. Okay. So here we say that left hand side is equal to right hand side. Left hand side is equal to right hand side. That is L. This is left hand side and this is right hand side L. So that means it is a dimensionally homogeneous quantity. Okay, this formula is a dimensionally homogeneous because if you see, we have separately solved left hand side, right hand side, and they both are same. So these type of formulas, if we came across, you can resolve it, that it becomes dimensional homogeneity. Okay. Now, the application of dimensional homogeneity is it is used to determine the dimension of physical quantities and helps to check whether equation is dimensionally homogeneous or not. Provides the facility to convert unit from one system to another, and also it provides a step towards dimensional analysis, which is widely used for the research work and the model test. Okay, so this is about the dimensional homogeneity. Next is the that is Rayleigh's methods for the dimensional analysis. Next is Rayleigh's method of dimensional analysis. Yes. So I just tell you something like, if suppose you are not going to understand it or you have not stored the videos, you just go to the my YouTube channel. You can refer these videos. I have just uploaded there. Okay, so you can just refer to that also for understanding purpose. In this method, the functional relationship of some variables is expressed in the form of an exponential equation which must be dimensionally homogeneous. This, if x is some function of a variables x1, x2, x3, the function equation can be written in the following general forms. So there is suppose the function of there is a function dimensional homogeneous, that is x is equal to f x1 x2, okay, and so on up to xn. So these x1 x2 x3 up to xn is the variables. Okay, these are the variables. In this equation, x is a dependent variable. This is dependent variable. Okay, and all these are independent variables. Okay, so a dependent variable is one about which the information is required, while the independent variable are those which governs the variation of dependent variables. So Rayleigh method is based on the following steps. First is the functional relationship with the given data. With the help of principle of dimensional homogeneity, find out the value of VBC. Okay, just I will tell you one example. From that, you just get the value of ABC. How to solve it? I will just okay. We just take the new slide. So the force acting on a propeller of an aircraft depends upon the variable that is V. Okay, V is the velocity, rho is the density, mu that is the viscosity, then d is the diameter, and n that is the angular uh, displacement. Sorry, rotational speed. Okay. So the force acting on the propeller of the aircraft depends upon the following variables. So I just write F is equal to F is the force acting F on a propeller, and F is a function of these independent variables. I just write v, okay, then rho, then mu, then d, and n. So force of a propeller is basically depend on these one. What we have to do? Deduce the formula for this force based on Rayleigh's method. This is the question. Question is actually it's not. We can say it's a question also, and we can also say directly this is the Rayleigh's method. Okay. Yes. So how to solve this? These are the independent variable. Okay. Yes. So for every independent variable, I just quote the name that is like A, then B, then C, then D, and at the last E, like this. Okay. So force in terms of fundamental dimensions, how can I write force? Force I just write it as M into L into T raised to minus 2. Okay, we have seen how to simplify this into a force. That is equal to K K. Okay, now V is what? Velocity. Now again simplify this velocity V in terms of fundamental quantities or the parameters. So velocity is what? L divided by T. Okay, so I just write L and T raised to minus 1 whole raised to A. Okay, then second term is what? Density. Density is what? Density is equal to mass divided by volume. So how to write the mass divided by volume in a fundamental quantities? So that I just write mass divided by volume means L raised to minus 3. Is it okay? Whole raised to B. The next term is a viscosity term. So viscosity term we have simplified. If we are not going to remember, you just first of all simplify how to write the viscosity. After that, we'll write it here. M L raised to minus 1 and T raised to minus 1. Whole raised to C. Then D, that is the diameter. So diameter we can write in terms of L whole raised to D. Then E, that is the rotational speed, that is N. So T raised to minus 1 whole raised to E. Bracket close. Okay. So these are the simplified way. Now next step is what? Next step is you just segregate the mass term, then length term and time term. So is equal to K. We just start with the mass. Okay. Mass M. Yes. So if you see the first, that is M raised to B. Okay, second bracket. Now just see how many brackets are there in previous terms. 1, 2, 3, 4, 5. 5 brackets. Because why? A, B, C, D, E. Okay. In that way, we have just make the brackets. So in first bracket, there is no term that is M. In a second bracket, in between inside B, okay, there is a M term. So I just write M raised to B here. Okay. The third bracket, yes, there is a M term. So I just write B plus C. Then fourth D, no M is there. E, again no M. So this is where we are just going to complete the value of M. In the same way, next term, that is L. Okay, again see the first bracket in A, L raised to A. So we just write A. Then L raised to minus 3, and outer bracket, that is B. So just minus 3B. Okay. The third term, that is third bracket, L raised to minus 1, and the outer bracket C. So minus 1 into C. Then the fourth term, that is L raised to D. So plus D. Okay. The next is time T. Time T. So just see the first bracket again, T raised to minus 1, and the outer bracket A. So T raised to minus 1 into A. Okay. Second bracket, no T term is there. Third one, yes, minus 1 into C. Next, minus 1 into T. So in this way, we have just simplified the previous step. Can I write for M, okay, we get B plus C. Okay, M is B plus C is equal to, in the left hand side, what is the value of M? That is 1, M raised to 1. Okay. In the same way, if you see L term, for L term, we get A minus 3B minus C plus D is equal to what? Is equal to, see the left hand side, L raised to minus 1. Sorry, L raised to 1. So you write it here 1. This is 1, this is 1. Okay. Then T, for T again, you just see that is T minus 2. So here you just write minus A minus C minus E, that is equal to minus 2. Is it okay? So this third term, I just modify the sign only. A plus C plus E is equal to 2. Is it okay? Okay. So the next thing is that I just convert the terms in, I just modify the equation, like suppose B, I can write it as B is equal to what? C minus 1. Sorry, 1 minus C. Okay. In the same way, how to write A? A is equal to what? 1 minus, sorry, 1 plus 3B plus C. Okay. Plus, sorry, minus D. Yes. And this term, that is, okay, once again, we just make a small change here. Yes, so can I write this? A is equal to 2 minus C minus E. Okay, and here this one, D is equal to, so D is equal to how much? So D is equal to 1 minus A plus 3B plus C. Okay. Yes, so that is equal to 1 minus A plus 3 into B. B term we just try to put it here. Okay, so B is equal to how much? That is 1 minus C plus C. So here if you solve this, you will get 4 minus A minus 2C. Okay, so the value of A is also there. You just put the value of A in this equation, 4 minus 2 minus C minus E. Okay, minus 2C. If you resolve this, you will get the answer 2 minus C plus E. So this is the value of D. So what I have done, I have just find out the value of ABC. You just see here, and that all are in terms of only CM. A, B, C, and D. Okay. So the next task is what? We just put the values in our previous equation. Yes. So put the value in terms of C and E in above equation. Above equation means which equation? Okay, which equation? This is our equation. That is, I just write it as first. Just change the color. So here F is equal to K into V raised to power A. A means what? That is 2 minus C minus E. Then rho raised to B. So how to write B? That is 1 minus C. Then mu raised to C. So C means already that is C. Then D raised to D. That is 2 minus C plus E. Okay. Then N raised to E. So E is as it is because we are writing in terms of C and E. Then if you again segregate, we are going to again segregate things. K, okay, row we just take it out from these terms. Then V is also a separate value, that is V square. Then D square. Okay. So in bracket, you will see that you will ultimately get to know that you can find mu divided by V into capital D into rho, okay, 4 raised to C. So all the C component at the one end and all E component, we just take it aside, N D raised to E. Okay, so you will get these terms. So we just say that at the last F divided by, if you take it in the left hand side, rho V square D square. is equal to f of the two terms, that is rho v d divided by mu and nd divided by v. Okay, so where the right hand side represents the function of Reynolds number rho v d by mu and the parameter nd divided by v. So rho v d by mu is the Reynolds number. You just see here. This value is rho v d by mu is actually the Reynolds number. Okay, so yes, so the force that is acting on a propeller, we just have reduced that by the release method, and it is depend on the Reynolds number and this factor, that is nd divided by v. Actually, it's a parameter. Okay, so today we'll just stop it here. If you are not able to understand it, we just see that again, because first time it is quite difficult to